Hi everyone, this is the lesson for 5.4, finding angles using trig. So just like last lesson, we're still going to use our calculators and we're going to use sine, cosine, and tangent. But this time what we're missing is not a side value, it's actually an angle value. So again, I gave you step-by-steps, so you can go back and read these or use these if you need to. And I put on there how to type this in because it's a little bit different for the backwards calculator. So let's get started. So we're going to start out the same way and figure out what trig function we're going to use, set up our equation, and then solve for our variable. The only difference is this time our variable is our theta instead. So we're going to label our sides just like before. Opposite of 90 is the hypotenuse. Opposite of theta is the opposite. And the other side will be adjacent. So I'm going to cross out the side we're not using. So what function is it when we have opposite and adjacent? Very good, it's tangent. So I'm going to write it out just like we did before. Tangent of theta equals opposite over adjacent. So as you can see, our x is not in our fraction, it's inside our tangent. So just like when you solve an equation, we use inverse operations to get that theta by itself away from the tangent. So when you do the opposite of addition, it's subtraction, and you would write a minus sign because that's a symbol for the opposite of addition. Well, for these, the symbol for the opposite of tangent is to write tangent to the -1. That means tangent inverse. So if I take the tangent inverse, inverses cancel with whatever thing we have. Okay, so the inverse of tangent will cancel tangent. And we do it to the other side, just like we do when you're like adding to one side, you add to the other side. So from there, these two sides cancel. So on that side, you just have a theta. On the right side, we have tangent inverse of 7.7 divided by 14. And I put it in fractions to make sure we type that in, that it's 7.7 divided by 14, and that's what we're taking the tangent inverse of. Okay, so to recap, to get the tangent gone, we have to do the inverse, just like you would if it was +2 or -5. So the inverse of tangent is tangent inverse, which is written as tangent to the -1. We do that to both sides, and now we have theta by itself. So from there, all we have to do is type it in our calculator, and it will give us an approximate value for our angle theta. So in a non-backwards calculator, it works out pretty well because we type it just like it says. So if you look right above sine, cosine, and tangent, it has like tangent -1, cosine -1, sine -1. So remember, those means inverse. So we just have to hit second to get to those. Some calculators are a little bit different, so just figure out which button you have to hit to get to them. I've even seen a few where you don't have to hit like second tangent, you can just hit tangent -1. There's the tangent -1 button. Okay, so then we would have what's in our parentheses, and in our parentheses is 7.7 divided by 14. And I know last time I said that sometimes you don't have to leave or add into that extra parenthesis, but for these I would make sure you always add it because we are taking the tangent inverse of that division, not just of 7.7. So put your parentheses in, hit equal, so then we get that our angle theta is approximately 28.81 degrees. So for these, I'm going to approximate to 2 decimal places as well. Remember, sometimes it could be different. And you always have to remember that we put the -1 there, we put the degree symbol there because what we just found was an angle. Okay, so for backwards calculator people, or if you're using your phone, we do it backwards just like we did last time. So the first thing that we have here is our division. So 7.7 divided by 14, then we hit equals, and then we have to do the tangent inverse. So we hit second, and then we get our tangent, and that's it. Make sure you don't hit equals again after that. That's our answer right there. Okay, let's try another one. Okay, so for our next picture, hypotenuse goes first, opposite, and then adjacent. So we're not using hypotenuse. So this is another tangent. So tangent of our angle equals opposite over adjacent. How do we get rid of our tangent? Very good. We do the inverse to both sides. It's going to cancel that out. So we get theta equals the tangent inverse of 3 divided by 3. So if we type that in our calculator, what do we get? Very good. You should have got 45. It comes out a whole number. This is one of our special right triangles. Remember from 5.2? So I just want to show you one thing about this. If you see that 3 divided by 3 is 1, you don't have to type in 3 divided by 3. You can just hit tangent inverse of 1, and it comes out the same. Okay? That would come out the same as if you actually typed in the 3 divided by 3, because 3 over 3 and 1 are equivalent values, so it doesn't matter. So if you want to reduce the fractions first, or if you know what it is in your head and it's easier to type in that way, then go ahead and do that. That's fine. Okay, so why don't you pause your video and do those next 4 examples that are in the middle, and then we'll come back and do one of the ones at the bottom together. So go ahead and pause. Okay, so here's what we got for those other 4 problems. The one up in the top was cosine, and we ended up with 68.49 degrees. The one on the next row is cosine again, 36.87 degrees. Tangents in the middle, again, 17.10 degrees, and another cosine, 48.19 degrees. Okay, so if you had any questions or wasn't sure, don't know how to type it in your calculator, make sure you write them down so you can ask me in class tomorrow. So let's take a look at one of the problems on the bottom. So this is doing the exact same thing, but this time they tell us to find the values of both angles. So if we look, we have an angle here and an angle there. So we're going to actually solve and find both of them this time. We obviously don't have to find this one because we know that it's 90 already. So I'm going to start with angle H. I'm going to put theta there just so we can see opposite, adjacent, hypotenuse. But I'm going to use the variable H instead of theta since we have that angle named. So hypotenuse, adjacent, opposite. No opposite means we're going to use cosine. So cosine of H, or again you could put theta, but I'm trying to be specific since we're looking for angle H. Since we're going to do another one, if we just put one theta, it might get confusing. Okay, so adjacent over hypotenuse. So we take the cosine inverse of both sides, we get that angle H is equal to cosine inverse of 6 over 10. Or if we could reduce that, what would it be reduced? Very good, 3/5. So we type that in our calculator, we get that angle H is 53.13 degrees, approximately. Okay, so if it helps you, I would redraw the picture again so you can look at everything from W's point of view. I mean, you could just erase, but since I love when you show your work, I wouldn't. I would just redraw it. So 6, 10, W. So now our theta is going to go here. So hypotenuse doesn't change, but opposite and adjacent do. So this time when we're looking for the other angle, we're going to do sine. So sine of angle W equals opposite over adjacent. So it's kind of weird how they're similar, huh? You remember that from the definitions, the pattern that they make? So sine inverse of both sides. So we get W as a sine inverse of 6 over 10. And when we angle W, when we type that in our calculator, we get that W is approximately 36.87 degrees. I rounded there. Make sure you're rounding correctly. Okay, so do you see anything special about angle H and angle W? There's a special relationship that always happens between those that we talked about back in chapter 1, so I hope we recognize it. But it also relates how sine of one angle and the cosine of the opposite angle relate together. They're always that special thing. Okay, so go ahead and pause your video and try the last two, and when you come back I will show you the answers. Okay, so here is the solutions for the last two questions. For this one they said find the value of both angles and the missing side. So to find that missing side I use Pythagorean theorem, and then for the angles we use sine and cosine. Okay, so make sure you write down any questions you have and we'll talk about them in class tomorrow. Warner out.